Before I overview my project, I'd like to first go over a couple of things. The first being the novelty of my program, as my website is the first to allow users to input climbs that then get graded, as opposed to websites in the past which have simply generated climbs using a recurrent neural network model. The second thing I'd like to go over is the fact that my project is essentially a microcosm of real world web development, as it has a front end and a back end connected with a web framework that is all run on an AWS server. So everything is on the cloud with the GitHub repository as well as the AWS server, and hence the website.
This is Criterion D of my computer science IA, so I will be showcasing the product. So to begin, to access the Moonboard grader for my client, Sam, who's a climber, you can first just either click the link or paste in the link, which I have copied to my clipboard, into any browser. So as long as it has access to the internet, this website will be accessible. So within the website, you can see first off, it displays the moonboard, and while it's not the most aesthetically pleasing, it looks much more fitting to the screen on a phone, which is the primary target of when this product will be used. And you can see there's the moonboard, there's an empty list of coordinates, and two buttons, namely grade, climb, and clear. So what you can do on the website is you can select holds by clicking them, and you can see it highlights them and stores the coordinates in a list, which is also stored as an array in the JavaScript. And you can click the clear button to empty the coordinates list and clear the board. So if I want to grade a climb, then I will first select these holds, and then I will click grade climb. But before showing what the grade response is, I will outline what's going on the back end when I click this. So I click grade climb, and I'll now outline what happens on the AWS server. So within AWS, there are a few main services that are essential for this project to run. The first I will outline is IAM. So what this does is it defines roles for basically the services to interact with each other and have the necessary permissions to share data with each other. So the main role I use is this top role, and you can see it has administrator access and also access for code pipeline and Elastic Beanstalk, so those two can interact. Now over on Elastic Beanstalk, I've created an environment within Elastic Beanstalk, which essentially allocates a server on EC2, which is Elastic Compute Cloud, I believe, on AWS. So in my environments in Elastic Beanstalk, I can click the health, and this instance is essentially the server with EC2. So Elastic Beanstalk basically abstracts a lot of the intricacies of manipulating EC2. So I can show that this instance is T3 medium, which is basically how much computational power it has, and there's the server. Now, moving on to code pipeline. This is basically what allows Elastic Beanstalk to interact with my GitHub repository. So here's my code pipeline, and what this basically does is it has the source code, which is the GitHub repository I've given it, and it has the domain of the Elastic Beanstalk site that it deploys the code to. So now going over to my GitHub repository, this is what is being run on the Elastic Beanstalk instance. So it should first be noted that these have defined names that Elastic Beanstalk is aware of. So it knows that an application.py file will run a Flask application, and the requirements.txt file is also has a defined name that Elastic Beanstalk knows which Python packages it will need. So this is good for its extensibility, as it has well-defined names. So beginning with the static files, there's the JavaScript, the moonboard image, and the styles. the most important is the JavaScript, and the JavaScript waits for a click of the grade button, and when that happens, it uses the Google Ajax API, and it sends a post request to the URL at GradeClimb with the coordinates of that the user has clicked. And what that then does is, in the application.py file, it waits for a post request from the GradeClimb URL, and it stores the data into coordinates, and then it calculates the grade of these coordinates with the calculate grade function. And the calculate grade function first loads in the network from the pickle file, and it reformats the climb data, and finally it returns the predict neural network function of the given the network and the climb. And predict neural network is within the network evaluation file, and it basically just runs a forward propagation on the input climb. Here updates the grade button on the website to display the grade. And again, this is all being run on the EC2 server, and you can see as we come back, it graded it as a V5, which is a relatively intermediate grade, which seems fairly accurate for this climb.
I am here at the Moonboard with my client Sam, and we are going to be going through the success criteria for the Moonboard app. For success criteria 1, would you say it gives sensible grades on all climbs?
I would say so.
For success criteria number 2, would you say it generally grades as good or better than you?
Generally, yeah.
For success criteria 3 and 4, would you say it is an easy and clean website that allows you to input new climbs?
Yeah, I can click the climbs I want, and it just shows up.
For success criteria number 5, would you say it allows for unrealistic or illegal climb starts?
Unfortunately, I would say that it does. It allows for some interesting climbs and some interesting climb starts that you wouldn't see on the Moonboard.
And for success criteria 7, can the app generate new climbs?
It unfortunately cannot.
And as you can see, for success criteria 8, you can use it on your phone as long as it is connected to the internet.